Jefferson Jacobs is the Riparian Restoration Coordinator for the Oregon Natural Desert Association. He's based out of Bend, Oregon. He's worked in the professional field as a biologist for nearly 3 decades in locations ranging from the Canadian and Alaskan Arctic to Hawaii's Big Island. Let's see here. It's kind of a overview of what he does. So he helps educate the ONDA, which is the Oregon Natural Museum Association volunteers, gaining them perspective and understanding as to the impact and significance of their work. His involvement includes these 3 focal areas: restoration, implementation, scientific inquiry, and education. Jefferson led to develop the BeaverHOODS, HOODS, conceptual model as a tool for aligning and guiding the needs and opportunities. You ready, Jefferson?
Yes, unmuted. Thank you very much. And share screen. All right, get a thumbs up there for the screen. All right, great. Thanks, and move people around. All right, thanks so much for allowing me to talk to you all this evening. I really feel like a small fish in a big pond getting to talk about BeaverHOODS as part of the speaker series and about how it's helped shape my thinking about beaver habitat and restoration. So thanks especially to whatever fluke in the vetting process let me in through the virtual door. I hope I can make this worthwhile for you, and I really am looking forward to constructive feedback. To get started though, here's what I'm hoping to cover in the next 37 or so minutes. There we go. First, I want to give you a little background as to why I felt I even needed to come up with a conceptual model like this, and then an abridged version of the thought process that evolved into BeaverHOODS. And then we can actually discuss the details about what BeaverHOODS even is. So by way of background, I've worked at the Oregon Natural Desert Association since the beginning of 2008. And I design and I execute riparian restoration projects that are implemented by teams of volunteers that I supervise in the field. What this really means is that a major part of my work involves motivating groups of volunteers to do what is really at face value just grueling, exhausting work, often in the hot sun or long hours. And it might be easier to trick them into doing this were it not for the fact that these are smart people who actually listen and then ask good questions. And to make it even more difficult, they are also people I actually really like. But I find that the more informed my volunteers are, the more enthusiastic and motivated they become. So the result of all of this necessitates being able to really truly explain how the work they're doing makes logical and ecological sense, how it's meaningful, how it's long lasting, and how it fits into a bigger picture on the landscape. It also means making sure that the projects we work on actually really do check off all those boxes. So what I needed was a tool to help with designing, vetting, and explaining worthwhile restoration projects. So where did this BeaverHOODS tool evolve from? Well, when I talk to my volunteers about riparian systems, I often start with the Stream Evolution Triangle conceptual model, or SET. I like to describe the SET as a flat triangular shaped plate or a tray that you can hold level in your hands. On the tray is a marble, and by gently tipping the tray, you can roll the marble around. Each corner of the triangle represents a suite of processes that influence the ecological state of a stream, what it looks like and how it behaves. There's the Geology Corner, Hydrology Corner, and Biology Corner. The marble's location on the tray relative to any of these three corners represents that corner's relative influence on the riparian system. An example of the marble solidly in the geology corner would be an incised channel, or at the most extreme, the Grand Canyon. In riparian restoration projects that I'm working on in the wild or rural parts of Eastern Oregon, our goal is to return a stream's condition to a stage zero state. For those locations, that means multi-branching channels occupying the valley bottom with an active floodplain covered in riparian vegetation and full of beavers. When you overlay the stage zero model onto SET, the stage zero condition lines up with the biology corner, showing its control on the stream. Various other stages of a degraded or recovering stream then line up with the other two corners. For example, that deeply incised stream here in the geology corner. In implementing riparian restoration to achieve the stage zero goals, then I'm engaging in restoration activities, or one engages in restoration activities that we hope will tip that stream evolution triangle and roll that marble intentionally towards that biology corner. An example would be an incised creek where we use beaver-based or process-based low-tech restoration tools to build a beaver dam analog to arrest erosion and start degrading the channel and move the stream's marble out of the geology corner. We can use these tools to influence the system and move the marble around. But in modifying conditions in this way, we humans are the drivers. We are the marble movers. Yes, we're taking advantage of natural processes and using tools that may be gentle or inspired by nature, but it's still really us behind the curtain making things happen. In this version of the stream evolution triangle, beavers are lumped into the biological corner. In the version of the SET that I teach my volunteers, I pull beaver out of the biological corner and place the beaver right on top of that triangle-shaped plate. It was hard to draw, but I like to describe the beaver as having a hind foot on the geology corner, a hind foot on the hydrology corner, and both front feet on the biology corner, shoving the plants in its mouth. Kind of like a nerdy beaver-based game of riparian restoration twister. I do this to represent the outsized and intentional role beaver can have on riparian systems. Beavers are ecosystem engineers. They can modify all these factors to create and maintain their ideal habitat. They can build dams that arrest erosion and degrade the channel, moving that marble out of the geology corner. These dams also can control how and when water flows through the system, wresting control from the hydrological corner. And they can create acres and acres of irrigated conditions, enabling vegetation and hyperrheic systems to flourish. I like to have my volunteers picture the beaver kind of balancing on top of the plate this way, sort of surfing along, keeping the marble moving around in a dynamic way that ends up maintaining its ideal habitat. My means to achieving my stage zero restoration goal then is to consciously and intentionally extract beaver from that biological corner to enable beaver to get on top of the triangle and take charge of moving the marble around. I don't want to be in charge of moving the marble around or leave it up to chance as to if I'm doing it correctly. I want beaver to be in charge. Humans cannot effectively replicate the benefits of beaver managed habitat on the scale needed. But to get those beavers playing twister for us, they have to have the right conditions to set up a colony, have that colony survive for multiple years, and have the ability, freedom, and tools to enable the active management of their landscape. How do we achieve those conditions? And how can we do work towards achieving those conditions intentionally and somewhat reliably? Well, that got me thinking about the details of how a keystone species interacts with their environment. Beaver are a keystone species. Just like that top block in an old Roman stone arch, the whole stone system depends on that keystone. The stone is removed, the whole arch collapses. In the case of beavers, the arch is the unique ecosystem they support. And the way the beavers support that ecosystem arch is by being ecosystem engineers. This is an important concept in that by definition, then we cannot have beaver habitat and all its associated benefits without beaver maintaining it. But often the conversation about this relationship kind of stops here and kind of glosses over some things. But here's a dirty little secret. Theoretically, if you take out one of those other principal blocks in the arch, that arch can still crumble. So in my mind, that raised two questions that needed to be explicitly pointed out. First, what is different about the beaver block's role in that arch that's so important that sets it apart from the other principal blocks in the arch? And second, what are those actual principal components of the arch? What do those other blocks consist of? To answer that first question, picture beaver surfing on the SET again. They have paws on all three corners and can intentionally move the marble around. It's this ability, this ecosystem engineer role, that sets them apart from the other blocks on the arch. Sure, yes, SET, the three corners, those all can influence the marble on the tray, but not to the synergistic conscious level of beavers. What this means then is if a block is damaged, a beaver can actively work on repairing it and will fix the arch. A key component of this, though, is that beaver need at least the rudiments of those blocks to construct their arch. They can assemble blocks and fix and improve blocks that are in really bad shape, but would be hard-pressed to create them from scratch. If our goal is to enable beaver to build or maintain an arch, we need to know what those blocks are. That way you can see if any are damaged or missing relative to the beaver's needs. BeaverHOODS provides a framework for looking at a given system and assessing, first in a general way, then with increased specificity, what may be the missing link or the missing block whose absence is keeping beavers from being able to move the SET marble in a meaningful way. So first we need to know what those blocks are. Depending on how you look at it, there could be all sorts of different blocks. Big blocks, little blocks, complicated interrelationships. But at the most simplest, what are the most important blocks that we have to have? In the interest of efficiency and simplicity, what is the least number of blocks that we can provide the beaver as tools that will then enable it to build an arch and play twister? Well, if we think back to the stream evolution triangle and the beaver interacting, I think there's a strong argument for that minimalist arch being constructed of just three main blocks. The tools that beaver use work on the hydrology, biology, and geology of the stream, all maintained and strengthened by beavers as the ecological engineer keystone. As a placeholder, though, I'm going to add in an emoji representing the human cultural landscape, and I'll talk about that more in a bit. So now we have a lot of ideas and concepts running around and images of beaver playing twister, marbles, stage 0, a really funky, poorly drawn Roman arch, and a vague conversation alluding to potential differences between beaver-based restoration and beaver-enabling restoration. But conceptual models are supposed to make things simpler and distill ideas, and really so far, I think all I've done is muddy the waters. So let's congeal these thoughts into a framework represented by a single simple image. This image needs to convey the interlinked dependencies of three components held together and managed by beaver, as well as considering that component of human culture. It needs to show how the weakness or absence of one of the components dooms the whole system to failure or inherent instability. And to do this all in a way that we could stand on the edge of a creek with this image in our mind and use it to assess the landscape in front of us, figure out what components we need to work on in order to enable beavers to manage the system for us. So The structure that I found which best exemplifies all these various characteristics that I've been using as the framework for the BeaverHOODS model is, and prepare to be underwhelmed, is a three-legged stool. Why a three-legged stool? Well, a three-legged stool is a parsimonious structure. It contains only the minimum components needed to get the job done. There's nothing extra, and without all its parts, it doesn't work at all. If you take away one of those parts, it doesn't work. You could add more different parts, but really with diminishing returns. Okay, with the stool as the structural framework for the model, let's name the components and then start drilling down into details and applications then of what BeaverHOODS is. The legs of the stool represent hydrology, biology, and geology, inspired by the SET as the minimum processes, but now as legs, reflecting them being critical components of the ecological arch, with Beaver in the driver's seat on the stool, acting as a keystone ecosystem engineer, holding the critical minimum three legs together and really making it all work. I have double-ended arrows on the leg labels. This is intentional and acknowledges that not only can Beaver push on these individual components to use them to modify their landscape, but that these variables have their own powers as outlined in the SET originally, and can still push back to modify landscapes and move the marble. That human cultural component is also represented within the seat, sharing space there with the Beaver. More on that still in a minute. But how do we turn this stool into actionable answers that can help us interpret the needs of beavers? When we get into the real specific details, just a reminder that this will be an Eastern Oregon-based interpretation because that's where I work. And so I want to make sure that people understand that what I describe is really just a starting point for people's own customization of specifics relevant to their part of the state or of the world. You'll see that in terms of project implementation, BeaverHOODS really actually requires you to incorporate your own observations and learning. So, standing on the edge of a creek or even checking things out on Google Earth before heading out, I'll often start with this human cultural bit first. Beaver may be an ecosystem engineer and they may be able to modify landscapes, but in most cases, they can really only do that if basically they have humans' permission to do so. So this human parenthetical, sharing the seat component with Beaver, reminds us of that. If you picture a beaver sitting on top of the stool trying to engineer its landscape, now imagine a human sitting next to the beaver on the stool. How much the human and beaver are fighting for the limited space on the stool seat will directly determine the ability of the beaver to maintain the ecological arch, keep the stool in one piece. Conflicts with humans arise in areas with infrastructure like buildings or farm fields right on the creek, or where there's significant competition for limited resources such as water or vegetation, or where there are high levels of physical disturbance, or where humans are going to be a source of beaver mortality. In locations with unresolved conflict, you can picture the beaver and the human fighting for space on the seat, like two kids in the back seat on a long car ride. I want to move the marble. No, I want to move the marble. Don't make me come back there. Depending on where the given creek lies on the spectrum of seat sharing with humans, the site might not be suitable for beaver enabling restoration right from the start. Or maybe the first step of restoring the reach might have more to do with education to human stakeholders about the potential benefits of beaver managed habitat. Options for beaver-human coexistence strategies, or just to reduce expectations as to restoration results given the human-derived constraints. It's important to note, though, that some human impacts may actually bleed in from outside the immediate reach you're trying to restore. If the neighboring landowner will shoot beavers on site if they swim across the line into his part of the stream, that's going to need to be considered. Or if, for example, an upstream neighbor is dewatering the creek for irrigation most of the year, that's going to need to be considered. Moving forward, though, for the process of describing the model, let's assume that there aren't any unresolvable human conflicts. What's next? Let's look at what in the SET would be called the Geology Corner, but I refer to as the kind of physical character leg. Well, in a conflict-free zone where we're hoping to work, studies like Scrafford et al. And my own personal observations indicate that beavers are really hard-pressed to have a colony lasting longer than 5 years in a row when occupying less than half a mile or 3/4 of a mile of stream. Could they take advantage of more? I'm sure they'd love to, but we're looking for minimums here for establishing a colony on this creek. Once we start considering the other stool components, you'll see how this kind of makes sense. It's hard to actually physically fit what a persistent beaver colony needs into a creek section much shorter than this. Sometimes it can be challenging to find the potentially rare locations where all these pieces of the stool can be made to align and work together. So at a minimum, we need to have a half mile of creek to work on. Above 3/4 of a mile in length, our efforts might get stretched too thin and diffused, resulting in diminishing returns. But this gives us our first filter, basically a 3/4 mile long zone. Yes, you can have a couple of these bumped up together, but again, these are the minimums. We can mentally slide this up and down the length of the available creek to see where or if any area can best encompass all 4 of those stool components. Next, beaver don't work so hot. Dams don't work so hot where stream gradient is too high. People may be familiar with the BRAT model predicting things like stream gradient effects on beaver dam densities. But beyond just dam persistence, when you're out on the ground in Eastern Oregon, getting gradients above 5% or up to 10%, seems like those steep degraded streams drain the limited seasonal precipitation extra fast and are more prone to creating even flashier flows. That might not only blow out dams, but also might just leave them high and dry. So I like to see things kind of in the 0 to 5% gradient range. This isn't a defining limit as to where beaver are capable of creating habitat, as much as it is a sliding scale as to where I am able to work most effectively at enabling beaver. Next, we need to look at the shape or topography of the land within 100 feet of the creek bank. We're looking for land that will be suitable for establishing or already currently contains sufficient vegetation, as well as an immediate landscape that has a topography that will enable relatively easy modifications by beaver in the future. In Eastern Oregon, within a given 3/4 mile long stream reach, what we're looking for is a minimum of 3 total acres of land within 100 feet of the creek bank. That's between 1 and 5 feet above the midsummer water level. Height above water helps assess the viability of establishment, persistence, and spread of vegetation that the beaver need to survive. On the ground, that typically is some sort of inset floodplain that looks like this. If I'm trying to establish vegetation, I need year-round soil moisture near enough to the ground surface for my new plants with their initially shallow roots to be able to reach it. To establish sufficient vegetation amounts, I typically build beaver dam analogs to temporarily raise water levels under dry inset floodplains like this. Depending on soil types, gradient, etc., I can usually raise water tables by a foot or 2. Depending on the planting methods I'm using, I can then dig down to that water table a foot or 2. So I'm kind of meeting in the middle there and get my plant roots to tap into it. Bridging an elevation gap higher than 5 feet is beyond the tool set that I have available to me. In general, though, this requirement is about helping you look at the landscape like a farming beaver. Where will I best be able to grow, access, irrigate, and modify my crops and fields along this creek? What does that vegetation consist of? I'll get into that on the Vegetation Lake. But for now, in regards to providing real estate available for farming beaver vegetation, again, according to Scrafford et al., 3 acres of vegetation within 100 feet of the creek is associated with colonies lasting 2 or 3 years at a time. Beaver colonies persist for more years as acreage increases up to about 12 acres, after which acreage doesn't seem to matter. 6 acres of vegetation is associated with colonies lasting at least 5 years. Why should this acreage be no less than 1 foot above summer minimums? This allows for room for beavers to raise water levels in the near future. Beavers need water for escape cover from predators. If they come in and build dams to increase and maintain water levels, you don't want to rely on vegetation that grows only and exactly where beaver will immediately submerge it more than just seasonally. So this is an attempt to kind of find a Goldilocks zone of wet enough to grow but not drown right away. It also helps fight that tendency of planting basically a beauty strip along the creek at the bottom of a deep incised channel. That beauty strip is just an almost useless volume of material anyway that'll just get submerged as soon as beavers start modifying things. Thinking about the topography around the creek being within these certain parameters also takes into account the possibility of beavers developing stream complexity in the future. Having 12 acres of accessible floodplain will increase the chance for stream complexity, which spreads out flood power, allowing dams to persist, and provides better irrigation for larger volumes of vegetation and safe access to it. Scrafford et al. Found that in their model that once the acreage of vegetation exceeded 12 acres, increased stream complexity helped explain a lot of the persistence of older beaver colonies. So we prioritize these areas where future small-scale beaver activity would have the easiest time of making that complexity happen. Okay, hydrology. Definitely one of the big questions is there enough water? Too much water would be more of a river that would be too big to dam, or just where there's just too much flood action for you to deal with. Since I work in a dry climate though, I'm focused on looking at the drier end of the spectrum. So by enough water, I'm really just trying to get an idea of if on average, I think there might be throughout the year enough total water to provide irrigation for the vegetation beaver will need. And if beaver move in and build some dams, will there be enough water to store temporarily to provide persistent escape cover that the beaver will need to stay alive, but year round? If there isn't enough water right away, are there things I can do to basically make more water? Can I build BDAs to slow water down during the plentiful times of the year? Can I talk to upstream irrigators about in-stream flows? I can't really give like a minimum CFS level needed. This is really a gestalt judgment based on visiting the creek at various times of the year and talking with people familiar with the creek. I look for where flood debris is deposited. I look for the persistence of mesic upland vegetation growing in or near the creek. If the stream bed is visible from the sky, I look at high resolution historic imagery of the area that you can view for free online. In general, perennial streams have enough water, even if they're small. If you're dealing with a creek that's potentially on the low flow end, it will be important to really spend as much time as possible working to inform this aspect. But just because a stream is seasonal or has dry sections doesn't mean that it doesn't have enough water. If a stream is flashy, but you can capture that water, you can make it work. Sometimes, depending on your goals and tools, that volatility can be a real asset to restoration. Sometimes dealing with volatility is all that needs to be addressed to enable beaver to take over management. After human conflicts were resolved, this was the case at Bridge Creek, where the spring floods kept washing out beaver dams. Providing anchor points allowed beaver dams to survive the floods and create a synergistic system resilient to the flooding. Another thing to keep in mind is that you don't need water everywhere in the creek at first, just in your 3/4 mile section to get the beaver started. these beavers in this picture are taking advantage of what is more or less a perennial spring, while just upstream, the creek is dry in midsummer. But the spring-fed site gives them a beachhead or a base of operations that they're expanding on as we work on restoring the dry parts of the creek together. Okay, let's finish with the vegetation lake. The 3-acre minimum of good vegetation has really held true when I go out and I map out vegetation available at various places where beavers have tried and failed to varying degrees in Eastern Oregon. Maybe on the west side where productivity is higher, you could get away with less. In the book Lily Pond, the author describes a beaver colony persisting on pond lily roots and leaves, and that we're getting by with very little terrestrial vegetation. So you need to look at and study your system to modify these amounts. Yes, beavers can eat forbs and weeds and all sorts of things in the summertime, but come winter, all they have is woody vegetation. They need woody vegetation to keep their teeth trimmed. They need it for dam construction, and they need it to eat. Will you see them building dams with all sorts of weird materials? Yes. Will they chew on trees that have no food value? Yes. But they have to have palatable, deciduous, woody vegetation for winter food. In most cases, this means aspens, willows, and cottonwoods. Just like anybody else, though, beaver have preferences. At the Clarno Nursery, when a beaver breaches the perimeter fence, it goes straight for the cottonwood trees. Beaver don't seem to care much for the ubiquitous coyote willow. On the west side of the Cascades, I've been told that beavers love dogwood and alder, but east side beavers don't love dogwood and only occasionally eat the freshest thin roots of the alders. Thank you very much. When you're looking at what beaver eat in your stream, be sure to differentiate between if it's being eaten or just being chewed on for tooth wear or being used for construction materials. So not all tree species count the same when calculating out how much food is available. An acre of preferred cottonwoods may be worth 20 acres of some less palatable species. But even an acre of the same species can contain different densities or different volumes of food material. I used to plant small amounts of willow and cottonwood at various locations along a creek in the hopes that over time it would establish and spread. And I've heard people refer to this as the poke and hope strategy. But I've come to realize that because of climate change, we don't have the luxury of decades for those few plants to spread on their own. We need that final density of riparian vegetation as soon as possible so beaver can start using it. So I plant my areas at densities much closer to what I want to see for a final product. I haven't found a lot of good guidance in the literature as to what those densities might be. So I'm guided by observations of how thick vegetation can grow and plant as close to that as I can afford. In the nurseries where I harvest my planting materials, they plant all the beaver species I use at densities of 1 stem every foot. And that vegetation is healthy and survives repeated heavy harvest like it would need to do in a beaver habitat. In helping to battle reed canary grass, I like to refer to the study by Kim et al., where they planted willows at various densities down to 1 foot spacing, and then tracked the resulting effectiveness of shading out phalaris. And these are results I've been able to confirm with my own observations in the wild. But because of budget limitations and logistics, though, I end up planting plants about 1 every 2.5 feet. That's a lot of plants. That's about 6,000 plants per acre. Right now, the easiest way I found to achieve these densities is by cluster planting sticks with a tractor-mounted auger. 2 people can get almost 1,000 sticks planted in a day that way, and because I can plant deeper down into the hyperrheic zone, I can get high survival even in Eastern Oregon. Deeper plantings also allow me to plant further from the stream, so I can achieve those acreage goals more easily by increasing the volume of my planted area from a narrow beauty strip to a big round exclosure. Sadly though, tractors can't access everywhere I need to work. In a nursery setting, you can harvest off of plants that are 2 to 3 years old. In the wild, where there are water fluctuations and all sorts of trials and tribulations, I hedge my bets and keep my plantings protected from beavers for a good 5 years before letting the beavers at them. But that 5 years is after the last plant is planted. If it took you 5 years to plant 3 acres, your first plants will be 10 years old before removing the entire project's fencing. If you remove fencing from each individual exclosure incrementally, as each one reaches 5 years of age, beaver will just eat that small volume down to stumps and suppress its growth while just kind of eagerly waiting for you to open up the next exclosure. It's the equivalent of feeding a starving person 1 potato chip at a time. It's better to give them a full meal all at once so that there are leftovers to carry them over into the future. So this all represents the minimum of what I think a practitioner or educator might need to know to guide thinking or to answer on a reach scale. Questions like, what reaches do I work on and why? What do I plant? How much? Do I need to build BDAs? When have I done enough? It lets me look at a place like this and see that we're pretty good on water. Beaver live at the mouth of the creek, so they could be present if conditions allowed, but they don't live right here now. It's far away from infrastructure, but hunting and trapping of beavers can take place, and there's heavy competition for resources due to cattle grazing. So I make a small, really weak seat. The 3/4 mile stretch has numerous inset floodplains like this or bigger, where beaver could farm some good vegetation. In terms of vegetation, there are a couple of tiny patches that could potentially be coaxed into expanding. But if I were able to have a good photo of the ground, you'd see tons and tons of various woody deciduous riparian plants that are about 1 inch high. So the vegetation leg is really hardly present, but has great potential. The solution for this location was twofold. We built BDAs to better irrigate and grow the existing vegetation leg faster. But we also built a riparian fence along several miles of the creek to exclude cattle. The fence was just completed this last fall, so we'll see how this goes. Compare that to this site, where no woody riparian vegetation has grown after cattle were excluded almost a decade ago. Beavers are currently unable to live through the winter here, so there's not even a seat. Without replanting the missing vegetation lake, no amount of BDAs are going to help this stretch of creek become beaver habitat in my lifetime. So I wish I had time to go into how BeaverHOODS helps me think of like a watershed scale strategy, but I'm out of time for now. So just 2 more thoughts before I stop. One is that if nothing else, I'm hoping that people will maybe think about their restoration objectives directly and intentionally creating conditions enabling beaver. If the end goal doesn't include a landscape being managed by beavers, that's totally fine. That doesn't work everywhere. But I'm also hoping that people are really thinking about what your system needs. You can't have the benefits of beaver habitat without beaver managing it. Are you okay with that? Will the ecological, hydrological, or cultural needs of the system truly be achieved just by a beaverless riparian habitat? If your end goal is to have beavers managing the system, then is your plan actually going to make that happen? Are your restoration activities removing all of the barriers that may be keeping beavers from taking over? Or are you just moving the marble yourself and hoping beaver will somehow do something? In situations like this, what happens when you stop moving the marble? The other thought is that all of this requires time on the ground, getting to know a creek. I think that's something that's often missing in the process, and that's often viewed almost as a luxury or extra credit thing to do if time allows, rather than a place to start. I'd just like to advocate for investing the time in establishing a more long-term relationship with a creek, more of a two-way conversation with humility, focused more on observing and listening to what the creek or the beaver need and operating in a supporting role, enabling them to achieve their potential on their own, rather than thinking we alone have all the answers. Thanks. And hopefully we can have some
Jefferson,
questions.
thank you very much. That was great. That was really great. We do have some questions coming in through the chat and the Q&A. And Alex or Sarah, do you want to read some of those off and pose those questions to Jefferson? I'm worried my internet connection might fail me, so you guys are probably in a better position to do it.
Do you want me to, Alex?
Sure, either way.
Okay.
I think first off, we're seeing a lot of round of applauses and appreciation. So thank you very much, Jefferson. Appreciate the talk and spending the time.
Okay, so first question is from Melanie Clem. It is, what in your experience is the greatest limiting factor for suitable beaver habitat?
Well, in most of the places you're working, you're not drawn to places without the water leg anyway. And so that's not usually it. And then when you're looking at the topography, it's amazing what beavers, I have photos of beavers like building 15-foot tall dams in a spring, and multiple instances of that throughout Eastern Oregon. So they can recover some pretty crappy places. But in my instance, in my experience, it's not enough vegetation and not enough beavers. That beavers are either getting killed off or whatever, and so they can't be there consistently. So they kind of move the ball forward, and then a dam blows out when they're not around, and it goes away. So they lose ground. But a lot of times there's a lot of low-hanging fruit where we could just change management and improve vegetation, but you have to have the beavers to make it happen. So
Here we go. I had to unmute myself. Are you ready for the next one?
oh yeah.
Okay, this is from Rebecca Russell. We are seeing beaver move into a 10-year old restoration site. I'm wondering whether to try to protect some of the new shade trees, as stream temp is a concern here, or let the beaver drive, or just let the beaver drive. What factors would you consider?
Well, I mean, that cultural landscape includes what the people around the place want too. So if you're going to like the ideal utopia of the model of the world, 10,000 years ago, no one was protecting trees, and stream temperatures were doing just fine. Somehow, if you have enough room for beavers to modify things and they're pushing water into the hyporheic zone, it's going to be okay. I have temperature gauges on Hay Creek at Cottonwood Canyon State Park, which is a not vegetated stream, and the beaver dams, when they come in, it's doing fine without shade and with beavers, I guess, because beavers are doing stuff even before my vegetation's ready for them. So I think it's like, well, if the people that live around that creek want some pretty shade trees, then protect those. But it also depends on, do you have enough vegetation? Because if you have a small amount of vegetation, beaver can just come in and mow it all down, be there for 2 years, and then leave. If that's going to mess things up, then that's not going to be what you want. So you have to think of how that dynamic is going to be. Picture your marble rolling around on the tray, and keep it where you want it. So beaver might need a little guiding there. Maybe the answer is to plant more trees, and then they won't eat the ones that you want to protect.
You're muted, Sarah.
There we go. Okay. So this one says, thank you for your great presentation. Can you talk a bit about whether water depth in your experience has been a limiting factor for beaver establishment?
So far, it seems like as long as it's deep enough that a beaver can be submerged, that's what they need. When you look at like when they build channels themselves off of a stream, little canals to access places so they can get there safely, it's like at a minimum, it's like a beaver shaped sized canal. Can it be bigger? Yeah, but that seems, picture yourself being a bacon with legs creature that everybody wants to eat. How much water do you want? So you want at least that stuff that gives you the ability to go away. So I don't know, that deep.
Okay. When installing riparian fencing, how long do you leave it in place?
Yeah, so I would leave it 5 years after I've planted the last plant. And I've seen other places that they're like, oh, look, it's all mature. And they open that one up while they're still planting the other stuff. Like I said, if it's a small amount, beaver can come in and chew that down in no time. So you need to have enough that they can't just eat all of it all at once. And that's why that 3-acre minimum is so important. You want to open up at least 3 acres at a time if you can. If it's less than that, they kind of eat themselves out of house and home faster because it's like a rotating crop. So that's why it doesn't really matter, I think, above 12 acres, is that by the time they've eaten this down, this has grown back up again, and then they eat that down, but this has grown back up again. So it's not like they eat an acre a year and then it's gone forever. No, it's a cottonwood tree can, grow 5 feet in a season or something like that. So if it's got roots. But when I build fencing, I have to be honest, I'm pretty cheapo about it. And so I build fencing that intentionally excludes beaver, but people are pretty disappointed when they think about deer or elk. I kind of try to discourage deer or elk. It seems like it costs $1 bazillion to build an Alcatraz to prevent elk from getting at stuff. But I can build a 4.5-foot tall fence that is annoying to them, and they seem to leave stuff pretty well alone. And for that lower price point, I can build a lot more fences and plant a ton more plants. And when they get washed out by a flood, then it's like, well, I just rebuild them. So
along those same lines, we have another question. Excuse me. Are there any other ways to protect your plantings beside fencing?
Yeah, there's great stuff that you can do on a kind of a more household scale. Friends over at BeaverWorks Oregon, they'll teach you how to paint your trees with this sandpaper kind of stuff, and you can put individual cages on it. But to achieve the volumes of plantings that I want to achieve, I have to have like big acreages of fencing. So just the work per unit effort is best with fencing. And so that's what I stick with. Oh, I just saw a question. So there was a question about less desirable species. I have done things where I've kind of tried to make like nature's fence kind of thing, where I'll intermingle beaver palatable species with unpalatable species so they can kind of hide there. Sometimes you'll see willow growing up, in my case, just in front of my house, willow growing up through an alder, and they don't like alder. And so that willow gets to grow and it kind of slows them down. It's like my dog bowl that has all these little ridges in it for my dog. So the dog slows down when it's eating dinner. I have a black lab, so you have to do that. So I will do that, but then also like I'll plant rose in there and stuff to be annoying to deer and everything. Do I have any sort of data or real observations? No, but it's kind of fun to think about. So good point, whoever asked that.
Have you seen the beavers interacting, commingling, or whatever with other types of species?
You see stuff on the web with like the beavers that have the nutria and everything on the dam and everything. But no, beaver are kind of secretive, and there's not a whole lot of people just really spending a lot of time with the natural history of it. If anybody has any cool details like that, I would love to know. Oh yeah. How can you tell what they're eating versus what they're sharpening their teeth with? So, you know, if they're, picture a big log like this and they're just kind of chewing into it, or like a juniper tree, and you just kind of cumulative observations that they just kind of are just chewing on it and doing that kind of chopping down thing, versus seeing the stripped branches. When you see those white bare branches, that all the bark has been chewed off, that's definitely eating it. I was just out walking with my daughter along the Deschutes, and we were realizing that if you're looking at an area where beaver aren't building dams, like on a giant river, you know that beaver, then there's only two options left. It's, well, they're either eating stuff to sharpen their teeth or for food resources, because they're not using it for building dams, because they can't dam up the Deschutes. So it's kind of a process of elimination in that case, of looking at that things and really dialing down that behavior. You can also kind of get an idea by looking, if you're lucky enough to see a storage cache or something like that, if they're of their sticks of getting ideas. And then there's food studies and stuff that you can do where you put out various sticks and stuff. They did that, Ananda person did that at a Bridge Creek when that project was just starting up. So, but their diet preferences, it's almost like it's per family. I work on one creek that they do not eat Oregon ash. There's a bunch of uncaged Oregon ash and they don't touch it. Literally the next creek over, the farmer that lives over there, he's like, oh my gosh, they ate all my Oregon ash. And so it's like, you really have to know your local family, kind of.
There's a question, have you ever been involved in beaver relocation? Or do you usually build it and let them come?
Yeah, I haven't, and that's a great question, because people are always like, well, I don't know if beaver can get here, or I don't know if beaver ever really were here and stuff. And I point to two things. One, beaver have been in Oregon for millions of years. The oldest beaver fossil is from the John Day. And so if you're, and that's 6 million years ago, granted it's slightly different species, but anyways, they've been around for a really long time. So basically, if your creek runs into anywhere that has a population source, eventually they could have been there. Now, can they get there now? Probably, yeah. You can see cool stuff where on the north slope of Alaska, beaver are actually climbing over the Brooks Range, traversing like barren, rocky talus slopes where there's actually tons of bears and wolves and wolverines and all sorts of hazards and stuff. And they're crossing over these mountaintops and then colonizing places on the north slope that are shrubbing up thanks to global climate change. So if beaver can get to those places, they can get they can pop over from the next drain in Oregon. And beaver relocation and translocation is not only expensive, but it can be really hard on beaver. And I really advocate for actually thinking about the beaver, not just kind of inhumanely, just as some like tool kind of thing. So.
These are there's another one.
We're getting a lot of questions. I don't know if we're going to get to all of them, but we'll do a few more and wrap up around right at 7 or so. So thanks everybody for the great questions. We'll try to get to as many as we can.
And if you do have additional questions, questions, I put my email there at the end. I'm really passionate about this thing and will answer way more emails than I probably should. But if you have questions, just please send them over to me.
Thanks, Jefferson. Go ahead, Alex.
Latest question in the chat. Can you put BDAs in incised creeks even if beavers are not present?
You can, but then that gets back to you are rolling the marble. Are you putting him in with the idea that at some point in time, beaver are going to come in and take over? If you're not, what happens when you're not rolling the marble again? What happens when those dams blow out? Are you going to maintain them? Or in my case, I put them in for just 2 or 3 years in order for vegetation to establish. So I don't really care about them beyond that point because the roots are down far enough. So yeah, you can put them in incised places without beavers there initially. It's kind of the what happens next kind of thing. So
there's a question. Says, have you done any rough math on the cost per reach of attracting or sustaining a beaver colony in an eastern Oregon reach? One that checks many of the BeaverHOODS boxes, but for example, you know, the vegetation flood needs, I guess, still trying to understand that, but do you have any kind of sort of feel for the economics behind it?
I mean, it can be really good. In this case, I mean, I'm using volunteers to do the labor, and so that keeps costs down. But in terms of an overall project funding point of view, then a lot of times that volunteer labor can be used as match, and then you get better funding for your project for the implementation, and it racks up like $100,000, $150,000 in volunteer time pretty quickly. And so the economics of that are really helpful. You know, you can't do big bulldozer stage 0 stuff everywhere. So we can't spend $1 million on everything. And sometimes if you're looking at a stream reach with BeaverHOODS, you can realize, oh, I don't even need to do the big hammer approach. I just need to build an exclosure fence, or you know, I just need to plant $50,000 worth of trees or something like that, or I just need to change how the water flows through here seasonally. If I can get the upstream ranch or user to just let a little bit more stream water in, then that's going to be fine. Or maybe you just need like some beaver posts to stop the dams from flooding out. And so I'm inherently kind of lazy. And so I'm always trying to get away with just the bare minimum. And so this tells you what's the least I can get away with to make this happen. It just is that sometimes it's not satisfying because you have to wait a little bit before it really takes off. So.
Get a lot of kudos about your visualization of the marble and tilting. You know, very cool way of conceptualizing it.
Grand.
Sorry, I may have interrupted there. We're right at 7 o'clock, and I think we will cut it off here. And we have recorded this. We're going to have it up on our website eventually. Jefferson's contact information is also on our website. So if you want to follow up with him on any questions that we missed or didn't get around to, it sounds like he's up for that. And thank you so much for participating. This is the biggest audience we've had for a speaker series yet. So very impressive. Great talk. Thanks a lot, Jefferson. And Alex and terrific. We hope to see you all soon, and have a good evening. Bye now.
Thank you.
Thank you, Jefferson.